So every year you get some questions on KC, and a lot of those questions on KC or equilibrium constants at A level are fairly samey. We're going to have a look at some of the ones that are slightly different here today, that require maybe a little bit of algebra, a little bit of extra thought. So these are not your standard ones. These are ones that are, as I said, slightly different. So maybe if you really think that you're cut out for these and you're well capable of them, maybe the first thing you could do is just pause the video and do it yourself, and then perhaps come back and have a look at the answer that I got. Right, so in all of these, basically what is happening is you are given the KC and you're being asked to work things out from the KC. In the majority of equilibrium questions at A level, you'll be given information asked to work out KC. Predominantly those questions are very much the same. You follow the same process, you come out with an answer, and it doesn't require a huge amount of challenge for the majority of A level students. These questions here do a little bit. So let's have a look at this question. Let's work our way through it. So a sample, I've got 2 moles of, so I'm just going to write the equation out up here so I have a little bit more space than the question provides. So we've got 2 moles of hydrogen iodide. Okay. It tells me that a sample of 2 moles of hydrogen iodide. So initially, I'll write I for initial. We had 2 moles of that. The volume, always remember, is 2 deciliters cubed. Sometimes that's important. I don't think it's going to be important here because the number of moles on the left-hand side and the right-hand side are important, are the same. So therefore, all the volume expressions would cancel each other out. And the temperature's of no significance either. So really, in this one, I can ignore the volume because I don't need to go from equilibrium moles into concentration. I could if I wanted, but it'll only introduce an extra step and increase the chances of me making a calculator error. So I've got a KC of 64. And what I've got to do is I've got to work out what is the concentration of the iodine at that particular temperature under those particular conditions. So let's get going here. So I'm going to put ICEC, for those of you who are not familiar with me. I stands for initial, C stands for the change in the number of moles, equilibrium, E is the equilibrium number of moles, and the final C is the concentration. So I'm just going to set these, say that my hydrogen iodide starts with 2, which it does. I'm going to say that it loses X number of moles. I can use a variety of variable things, but I'm going to just use X here. So at equilibrium, I'm going to have 2 minus X number of moles of hydrogen iodide left. Over here, I'm then going to have a half X, because the ratio of hydrogen iodide to hydrogen is 2 back to 1, and I'm going to have the same here. Half X. So if I write that into my KC expression is 64 equals half X squared divided by 2 minus X, which is also squared. Hopefully you can see why I could leave the V values out here, because on the top line I'm going to have V squared, and on the bottom line I'm going to have V squared. So I just left that value out. You could do the calculation with that and come out with the concentration value at the end if you wanted. I'm just going to leave it out, and I'll calculate concentration at the end by dividing my moles by 2 by the volume. Okay, the next thing I'm going to do, I'm just going to square root everything here. So that becomes 8 equals half X over 2 minus X. And then I'm going to go and cross multiply very simply. So that becomes 16 minus 8x equals, of course, half x times 1, or half x. That becomes 16 equals 8.5x. So x equals, let me just do this quickly on my calculator. So that gives me x coming out at 1.88. Now remember, we've got to get the concentration. So X is the number of moles of hydrogen iodide that reacted. But remember, the number of moles of iodine, which is what we're after here, the number of moles of iodine is half X. So X over 2, or half X, gives me the number of moles of iodine that is made is 0.94. Now that's not our final answer because that's number of moles. Number of moles. Concentration is what we have to get to. Concentration equals number of moles divided by volume. The volume is 2, and if I divide that by 2, it comes out at 0.4. 0.47. So the answer is B. Now, some of you are maths, very good at maths, or pretty even adequate at A-level maths will find that fairly straightforward. But a lot of A-level chemistry students who maybe don't do A-level maths will find that reasonably tricky. So that's the method that you follow. Again, we're going to look at the second one here, which is sulfur dioxide, which is kind of a variation on the theme that we've just looked at. So again, if you want to pause the video, have a go at it yourself, that's fine. Okay, I will work through it here on the screen. So we've got sulfur dioxide. So I'm going to write this out so I can put my information below it. Okay. We've got sulfur dioxide in a 20 decimeter cube container. Now this time I'm not going to be able to cancel out my volumes because I have 3 volumes on the left and I only have 2 on the right. So they're not going to be able to cancel out, okay? It says at equilibrium, so actually I don't need to do my ICEC this time. Okay, I can get rid of that and I can get rid of that. So it tells me that I have 8 moles of sulfur dioxide, okay, and I have 10 moles of sulfur trioxide at equilibrium. And I'm just going to work out, well, what I've got to work out is obviously the X value for how many moles of oxygen do I have at equilibrium. The Kc value is 27.9, so let's just pop this all in here. So we've 27.9 equals 10 over, now don't forget to convert it into concentration this time, so it's 10 over 20, and that's going to be squared. My bottom line is going to read 8 over 20. That is once again squared, and that's multiplied by X, and of course X is the number of moles, and that's going to be over 20. I don't need to square that. Okay? I'm just going to put in all the steps, guys, because these videos are essentially designed to help people who struggle a little bit with the mathematical aspects of the chemistry. So I'm going to put in all the steps, or all the steps that I think are necessary. Some of you who are much more gifted at maths will be able to skip out some steps, I'm sure, and that's fine. Okay, so my top line now reads 0.5 squared. Let me just do my bottom line, 8 divided by 20. So 8 divided by 20 is 0.4, that's going to be squared, and 20 over X, or X over 20, I think that's 0.05, isn't it? Yeah, so that's 0.05, 0.05X, yeah, 0.05X, okay, right, oh, sorry. Okay, so let's do that. My top line then, because I'll just move over here. So 27.9, 0.5, I'm going to get rid of all my squares. Okay, 0.4 squared is 0.16, so 0.16 multiplied by 0.05x. So I'll just solve the bottom line, 0.05. Okay, so that gives me 0.25 over 0.008, and remember that's 0.008x. I've just multiplied those two terms out. Okay, so 0.08 multiplied by 27.9. I'm just cross multiplying here, by the way. Okay, that gives me 0.2232x equals 0.25. So I can now work out what my x is, okay, by dividing 0.25 divided by 0.2232. So my x is 0.25 divided by, just write it out, 2, and my x therefore comes out at 1.12. Now the question was the number of moles, okay, and that is the number of moles. That is my x value, and remember up here I said x was the equilibrium number of moles, so I don't have to do anything to that. Okay, I've already accounted for the concentration in an earlier step of that. Again, hopefully that helps. Okay, you can see the steps involved in that. It's slightly different from the previous one, but again, it's a bit of a variation on the theme. Let's look at the third one. Okay, so again, we have, you can have a read of the question. Again, see if you think you can manage it yourself, and if so, just pause the video and do it. So we have a carboxylic acid, so I'll just write acid, plus an alcohol, going to an ester and water. It tells us in this question that we've got to make, so I'll just write ICE, I don't need the C again because you can see moles on left and moles on right are the same. So my volume will cancel each other out. So there is a volume here of 50 cubic centimeters of water. Okay, I can ignore that. You can incorporate it into your calculation if you want. You don't have to. And like I said earlier, the only thing that it will do is increase the opportunity for you to make a calculator error. So I would avoid it, but I'll leave that up to you. Okay, so we've got to make at equilibrium 58 grams of this, and if I calculate out the RFM of that ester, the RFM of that ester is 116. So 58 grams is equal to 0.5 moles of that. I'm going to start off up here with 45 grams of my carboxylic acid. My carboxylic acid an RFM of 60, so that tells me I'm going to start off with 0.75 moles of that. Now, my ester, I have made 0.5 moles of it, so therefore I'm going to use up 0.5 moles of my acid. It's going to leave me with 0.25 moles of acid left over at equilibrium. I'm going to have X moles, I'm just going to use X moles of that alcohol left at equilibrium, which means I would have started with X plus 0.5 moles of it. My water, now this is where people can get caught out, and it'll bring to your attention that they've given you the density of water, so therefore I start off with 50 grams of water. A lot of people just ignore the water, think it's a volume, but it's a product in this particular reaction, so you do need to be careful here. Okay, it has to be incorporated into the equilibrium equation. So that starts off at 50 divided by 18. It's just mass over RFM. So the moles of water that I have to begin with is 2.7. I will, of course, also make 0.5 moles of that for the simple reason that they're made in a 1-to-1 ratio with the ester. Okay, I'm now ready to start putting things into my equation, my Kc expression, I should say. So that means that 3.0 is equal to 0.5 multiplied by 3.2 divided by 0.25 times whatever X happens to be. So 3.2 multiplied by 0.5, sorry, is of course 1.6. Let me just double check that. 50 divided by 18 is, sorry, that's actually 2.78. Okay, so that should be 3.28. All right. Keep the values right. So 0.5 multiplied by 3.28 gives me 1.64. I would introduce a bit of an error, guys, so just because there's a double check that my calculator, because I sort of thought that didn't look quite right. Okay, and then we have on our bottom line, which is 0.25 times X, which is 0.25X. I'm going to cross multiply now, okay? So that tells me that 0.75X is equal to 1.64. So 1.64 divided by 0.75 will give me what my X is. So my X is equal to 2.186. Now I've got to find, in this particular one, I've been asked for the mass of butanol. At the minute I've got moles of butanol at equilibrium, but remember, that is X. The mass of butanol that I had to start off with had to be X plus 0.5. So if I add 0.5 to that, that gives me 2.686. Okay, and if I multiply that then by the atomic mass, the molecular mass, which is 74 for butanol, that gives me an answer of 198.8 grams. So my answer should have been 199 grams. Okay, let's have a look at this particular one here. So this time we have a Kc of 39, okay, and we've got a nice simple little equation of A plus B. Okay, so if we're going to start with 2 moles of A, and we're asked how much of A is left over. How much of A is left over at the end. Okay, so let's have a look at this one. I think this one's probably a little bit. Okay, so I'll just write my equilibrium down here. My initial moles, my change of moles, my equilibrium moles, and my concentration. Again, you can see the moles on the left and the moles on the right are the same, so I'm actually going to just probably cancel out my volumes here. Okay, so we're going to start with 2 of that, there's none of that in there according to that. We'll say that the number of equilibrium moles of that is, we'll call it A. So the number of moles of B at equilibrium must be 2 minus A. If that makes sense. Hopefully it does. The concentration would just be those over V and that over V. So you can see hopefully by now why I would cancel out the V. So if I write in my 39 equals 2 minus A over A. I've cancelled out the V's there, by the way, for those of you who are on the ball. So that means that 39A equals 2 minus A. If I bring that across, that means 40A equals 2. So therefore A equals 0.05. And that is moles, remember, okay, because I hadn't gone as far as concentration. So that value is moles. Okay, so the question is how much would be left at equilibrium? Okay, so it is indeed, I've calculated out A. That tells me how much is left at equilibrium. In other words, that is my answer. Okay, let's have a go at this question here, which is S&T. It's pretty much the same, to be quite honest with you. The only difference here is that it's asked us about percentage of S that is converted to T. So let's again bring this down to here. Let's write in the information we've got. So our Kc, we know, is 24. Yep. Okay, and it asks us what percentage. So, I mean, again, you could start off with whatever you want. I think if they're going to ask me percentage, my initial change in equilibrium, I'm going to just start off with 100 moles of that. 0 moles of that to begin with. So let's say I make moles at equilibrium. I've got P moles, so plus P moles of that, if you like. Okay, and that becomes 100 minus P, of course. Okay, that should be, I've done that wrong. That's equilibrium moles there. Okay. So this will be 100 minus P. It doesn't really matter actually. So that can be changed. Okay. Again, my concentrations then. Sorry, I've just put in concentration without writing it down. My concentrations would be that. So I'm just going to cancel out my V's because top line and bottom line with the V on will of course cancel each other out. So this becomes therefore 24 equals P over V divided by 100 minus P over V. So again, I've just said the P's there, but I've got rid of them. Okay, I cross multiply that, so that becomes 2400. Okay, minus my 24P, and that equals P. Okay, a quick bit of algebra makes that 25P. I bring the P over. Okay, equals 2400. And my P, therefore, equals 96 or 96%. Okay? So that tells me that my the percentage of S that was converted to P was 96% of it is converted across to P. Right, guys, hopefully those, I think I've probably, well, I'll do one more, okay, this one here. Okay, calculate the fraction of P converted. So this one's actually very similar, okay? The only difference, I suppose, in this one is that you have not got that nice 1-to-1 ratio. Okay, so probably worthwhile actually doing this. So let's just give ourselves a bit more space here. Goes to Q plus R. So we've got to calculate what fraction. We've got a Kc, which is 36. Okay, and we've got to calculate what fraction of P. Now, when I do fraction questions, what I would do is I would always use 1. When I do percentages, I'd always use 100 as my sort of starter one. But, you know, you can use generally whatever number you want. But I think 1 and 100 makes sense. So we've got 1 of that, 0 of that, and we have 0 of that. Okay. Let's say the change of this is, we'll call that X has changed. So I'm starting with, at equilibrium, then I have 1 minus X. Okay. Over here, I will have X over 2, and over here I will have X over 2 as well. You'll see there's no volume in the question, and I don't need volume because all my volume terms on the top and on the bottom, hopefully you can see by now, would of course cancel each other out. Okay, so X over 2, or it's better to write that 0.5 X, guys and girls. Okay. So let's go to my KC. My KC is 36. My top line will read 0.5x squared. Okay? And my bottom line will read 1 minus x squared. Okay? If I go from there, I can square root everything here. So that means that 6 equals 0.5x over 1 minus x. Okay? So that gives me 6 minus 6x equals 0.5x, which gives me 6 equals 6.5x. Okay? So if I go from there then, okay, let me get my calculator at this point. So 6.5 divided by 6 gives me 1.083. Okay, so x equals 1.083. Okay, so my fraction equals 1 divided by that. So the fraction of p that has been converted, okay, is equal to 0.923 is the fraction, or if it was percentage, it would be simply 92.3. The way I got that is 1 over 1.083. Okay, gives me my fraction of p that has been converted into, in this case, Q and R. Okie dokie, guys. Look, I hope that helps. Some of those questions pop up, and they can be they're usually worth about 4 marks. They're quite mark heavy, so make sure that you can do them. Okay, all the best.